Welcome viewers. Today we'll be discussing the poster for the F402 Harrier hot nozzle. The objective of this project was to develop a measurement method for the F402 Harrier hot nozzle for the Harrier jet itself. Some important specifications to go over was to measure the throat area, and that measurement must be within 291 to 294 square inches. The area must be repeatable within 1/8 of a square inch, and the design life must last 10 years or at least until the Harrier jet's retirement in 2028.
The current procedure to measure the hot nozzle can be broken into 4 steps. Step 1. Mount hot nozzle to the measuring fixture. Step 2. Trace inside of hot nozzle with stylus. Step 3. Using a planimeter, calculate the area of the trace. Step 4. Repeat trace and calculation process, then average your results. A proposed procedure can also be broken into 4 steps. Step 1 is the same. Mount hot nozzle to measuring fixture. Step 2 will include the setup of our new device under the hot nozzle. Step 3, press start on HMI and let the device run. Step 4, use MATLAB script to calculate the area.
Looking at the hardware design section, 2 pictures can be seen that depict the design the team has constructed. The photo on the left is an isometric view. Fixed to the top of the design is a laser measurement device that will measure the area of each throat the laser is placed inside of. The height will be adjusted using the telescoping tube the laser is attached to. The photo on the right gives a top-down view of the system to display the linear rails. The team designed a translating table that is able to move in the X, Y, and theta directions. Movement in the Y direction is done manually and secured with plunger pins at set locations in the middle of each loft. The X and theta directions are driven by motors and the path is pre-designed.
For the electronics, we have designed a system that utilizes a PLC controller that will command the 2 motors as well as store information from the laser. The laser value represents the length R, while the 2 motors will represent X and theta. Once the PLC has these values, it will calculate the actual X and Y position and fill 2 arrays with these values. These arrays will be then uploaded into the MATLAB script that will plot the trace and calculate the area. There will also be an HMI or human-machine interface that shows the status of the trace as well as a start and stop button.
Under the prototype completion and testing section, we have described 3 variables that we believe are important. Throughout the completion of the process, we have a few variables that will remain the same: the path that the laser follows each time, the Y location of the rails, and the MATLAB script. The variables that we change each time will be the height of the laser inside of each nozzle. We want to find the difference between 1/10 of an inch, 1/20th of an inch, and 1/40th of an inch. Finally, to complete this project, the parts need to be ordered and assembled, the electrical components need to be assembled and code written to talk to them, and in-house testing needs to be completed to assure that all systems are working.
For our final product, we expect to have a mostly automated system for measuring the hot nozzle throat area that requires minimum training to operate. We also expect our system to produce area calculations that meet our accuracy and precision requirements.